The content of this video is intended for service technicians. The procedures and processes depicted are to be performed only by trained technicians. All procedures and processes were filmed in a controlled environment. Some safety equipment and/or safety guards or barriers have been removed or foregone for visual clarity. Always read and apply the general and specific safety rules and safety messages presented in the appropriate service manual and operator's manual. Always wear appropriate personal protection equipment.
Hi, it's Russ with the technical training team, and we're going to show you how to check concave levelness and concave side shift on an axial flow Flagship combine. Now, to facilitate the process, there's a home-built harness to move the concave up and down. We'll show you how to make that in just a minute. And then you're also going to need to make yourself some feeler gauges. Now, these feeler gauges have specific dimensions that they need to be made to. It depends on whether you're on a large tube rotor or a small tube rotor as to what those dimensions are. Now, we've got 4 of them made up here, 2 of them for a small tube rotor and 2 of them for a large tube. So if you're on a large tube rotor, the 2 that you're going to want are an 81 millimeter gauge and a 75 millimeter gauge. And then if you're on a small tube rotor, the 2 you're going to want is 113 millimeters and 107 millimeter. So you're going to need a different set of gauges whether you're working on small tube rotors or on large tube rotors. So let's get started with the process. Okay, so to start the process of measuring and adjusting level and side shift, we're going to remove the front 2 right rotor modules. So number 1 right and number 2 right makes it much easier to check the level. And through the magic of video, we can make them disappear just like that. And to make the job a little bit easier, we're going to use a home-built harness here, and you can construct one of these at home as well. Consists of a 2388 concave adjust switch, a couple of clamps to go to the battery, and then a connection to go to my concave adjust motor. And when I get this installed with the battery into the concave motor, then I'm going to use the switch to move the concave motor up and down. It just makes the job a little bit easier than having to run up into the cab back and forth all the time in order to adjust that. So we'll get the tool installed and we'll show you the next steps in the process. Okay, so we're installing our special tool, and we've got the cables going back to the battery box and hook it up to the battery. We've got our switch, and then what we want to do is we want to unplug our concave adjust motor and plug our other harness into that concave adjust motor, and that allows us to move the concave up and down with the switch. Okay, so we've removed the number 3 left rotor module to make it easier to spin the rotor. We've installed our home-built tool to adjust the concave up and down. Now that we've got the front 2 rotor modules removed, the number 3 rotor module removed on the other side, and our special tool installed, now we can use our gauge tool and check for level. Now, the gauge tools will either be the 81 millimeter or the 113 millimeter, depending on if you're on a regular tube or small tube rotor. And since this is a regular tube rotor, we're using the 81 millimeter gauge tool. And what we're going to do is we're going to take this gauge tool and we're going to put it all the way down at the front of the number 1 concave, but we're going to be on the left side, and we're going to stick it up through the bottom and hook the gauge tool over the top of the last rub bar and measure the distance between the rotor skin and the rub bar. And we're going to use our tool to run our concave motor up and down until the front is exactly at 81 millimeters. So we're going to take our 81 millimeter gauge tool, and we're going to go all the way to the front of the number 1 left rotor module, and we're going to hang the gauge tool over the last rub bar at the bottom. And then we're going to use our special tool. We're going to close the concave up until the gauge tool just touches the rotor skin. And we're going to try to wiggle it up and down and see if there's any room in there, and there is, so we'll go a little bit tighter. And now we're just exactly at 81 mil. So we'll come up until we're just 81 mil. There we go, and we're at 81 mil. And now we can remove the tool, and we're going to leave the concave at 81 mil in the front, not only to check the level, but we'll also leave it at 81 mil to check the side shift. Okay, so we'll take our same gauge tool that we used at the front, and now we're going to go to the back of the number 2 left rotor module, stick the gauge tool up through and set it on the rub bar. And we're going to measure the distance between the rub bar and the rotor skin. And if the tool fits in with no clearance, we know we're level. If there's not enough clearance to get the tool in, then we know we have to lower the back down a little bit. And if there's too much clearance, then we'll have to raise the back end up, because the levelness adjustment is made on the left rear corner of the carrier module frame. Okay, so if we need to adjust the levelness of the concave, we're going to do it right back here. So this is on the left rear corner of the number 2 rotor module on the left side. And we've got a clevis here, and in order to adjust this, we're going to have to take the pin out and then adjust the clevis to make this back end either higher or lower based on our gauge tool reading down at the bottom. So this is where we're going to make our concave level adjustment. All right, so we're going to check side shift next. Now, before we check side shift, we want to make sure that the concave is level, and we want to make sure that we're at the right distance from the rotor skin. Now, if you're on a standard tube rotor, you'd be at 81 millimeters, and if you're on a small tube rotor, you'd be at 113 millimeters. You can't do side shift unless you've got it leveled and at that right dimension, because the dimensions don't work out unless you're at the appropriate distance at the bottom where we did the levelness. Now, what we're going to do is we're going to take our gauge tool, and the gauge tool depends on whether we want it to be centered or shifted left or shifted right. And in this case, we're going to use a centered distance. So we're going to, this is a standard tube rotor in this machine. So we've got an 81 millimeter gauge tool here, and we're going to go to the front of the number 1 left concave, and we're going to count down 3 rub bars. We're going to stick this gauge tool in there, and we want to measure the distance between the rotor skin and the rub bar. And we want to make sure that we're at 81 mil. If we're not at 81 mil, then we're going to have to make the adjustment over on the other side of the combine. Okay, so what I'm going to do is I'm going to take my 81 millimeter gauge tool, because that's what I need on this machine. I'm going to count down 1, 2, 3 rub bars, and I'm going to slide the gauge tool in and hook it over that rub bar, and I want to measure the distance between there and the rotor skin. And I've got just a little bit of wiggle room in there, but if I had either, I couldn't get the gauge tool in, or if it was too wide, then I'd want to make the adjustment. I'll make that adjustment over on the other side of the machine. Now, that's the front, but I also want to adjust it at the back as well to make sure that the concave is square in the machine as well. So now we're going to move all the way to the back of the number 2 concave, and we're going to use the same gauge tool, and we're going to count down 1, 2, 3 rub bars. We're going to stick the gauge tool in there and hook it over the rub bar, and we're going to measure the distance between the rub bar and the rotor skin. And this one's got quite a bit of room in it, so this one could use adjustment. And we're going to make that adjustment over on the other side of the combine to tighten this up a little bit. That kind of indicates that this concave is not quite square in this machine. It's off by a little bit, and we could tighten it up a little bit. Okay, so if side shift adjustment is needed, we're going to do it over here on the right side. This is the right front. There's also one at the rear. We're going to use this draw bolt and loosen these clamping bolts in here, and then take the draw bolt and move the carrier module frame left to right until we get our side shift measurement correct, based on whether it's a small tube rotor or a standard rotor, and whether we want it centered or if we want it shifted one way or the other. Okay, so that's the process of checking and setting concave level and side shift. Now remember that making your gauge tools is the appropriate thing to do to ease the job, and a special tool to raise the concave up and down makes it a lot easier. Just a couple of key points is remember that the gauge tool that's used for level at the front, you check it at the back and set level first, and then make sure that the concave is level and at the level opening for the appropriate size rotor. So either the 81 mil or the 113, depending on if you're on a regular tube or a small tube rotor. Now the next question is why would you ever check or set this? Well, first off, it is on the pre-delivery checklist, so you should be checking it on pre-delivery. But then after a machine has been delivered and in the hands of a customer, the best threshing performance is with the concave level and centered. So for a regular tube rotor, that would mean 81 level and 81 side shift. That's where we get the best threshing and separating performance. Sometimes though, in high volume crops like corn, we tend to be a little bit right side heavy. And in order to settle a right side heavy machine, we might shift that concave towards the right side, which means we would use a different gauge tool, a smaller gauge tool, in order to move the concave module carrier frame over to the right in order to change the way that the grain is going to come out of the rotor modules and lay on the grain pan. And that's why you would check it on an existing machine after it's been delivered to a customer to even out that grain pan. So that's the process for checking level and side shift on an axial flow flagship combine.